Hey, good afternoon, guys. Welcome back after break. Um, I graded half of works and I will finish grading the other half today. Um, I mean, homework 4 on attention. So, I hope you saw the announcement. I had to make some changes in deadlines because of the break. So we let's see. Oh, I believe there is a mistake. I believe homework 5 is due today. And let's see, maybe I didn't update. Maybe I updated syllabus. Yes, homework 5 is due today. And I decided to cancel one homework, so we'll have less homeworks. So you have also homework 6 on GPT model. So homework 5 on BERT, homework 6 on GPT model, um, which is due next week. Yesterday I uploaded the new homework on parameter efficient fine-tuning. And this is the first homework that you can also use as a final project. So we will have homework on parameter efficient fine-tuning. We will have homework on reinforcement learning with human feedback, which is the topic of this week. We will have homework on quantization of LLMs and on the RAGs, retrieval augmented generation. So 4 more homeworks. And I uploaded links to, so for example, for homework 7, there is homework which is to use the built-in library for parameter efficient fine-tuning to create the trainable what's called prefix embeddings to continue this phrase in a different way that a quick brown fox didn't jump over lazy dog. And the first part is to, instead of using manually created this dummy embeddings as we did last time, use the built-in PEFT library. And the second part, actually, I looked at the implementation and it will be to implement the low rank adapter because it requires only 2 or maximum 3 lines of code. So I decided it's a good exercise just to implement matrix product here. And I provided the rest of the code with actually adding these layers to the model and also training loop. Hugging Face library has also training loop functionality. So here is example how you can train the model with this transformer trainer module, where you indicate the parameters like learning rate, warm-up steps. As you remember, we in training large language models, we first increase a little bit the learning rate and then decrease. So instead of writing your own training loop, you can use trainer.train, and it will so if you use report to none, it won't create a report. If you use like default report to none, it will write the logs into 1 dB. So here is example. If you log in to this 1 dB, weights and biases. So you can click on the logs from this training, and you will see these metrics in real time or after training after training. So like the schedule of the learning rate, the size of gradients, and so on. I'm just saying that because to run this code on Colab, it will ask for a token from this WhenDB library. If you run this in Kaggle, you might see just warning, and it will actually wait for 1 dB token unless you set this to none. Yeah, because I was trying to run this on Kaggle, and there was just rotating this run circle, and I couldn't understand what's happening. Then I tried on Colab, and on Colab it just provided the box where we're asking to import to insert the token from 1 dB, and after that it started training. Then I asked ChatGPT how to avoid this and behavior, and it says I should use none if I don't want to report to 1 dB. Okay, so this is the next homework. And after that, your model should provide the correct, from your point of view, text. And if you look, oh, if you look at the links for this week's, so for example, here I posted the links, ideas for the project. Actually, you will see the homework from Yandex Data School, and their homework contains additional actually problems. For example, here to fine-tune your large language model on the data set for code creation. So you can use these as ideas for the project. So I didn't include this in the homework, but you're welcome to complete this as a project. So this is for fine-tuning. For another week, so you can look at these homework assignments from Yandex, and maybe you will find the ideas for the project, like data sets, the goal. For example, here they ask to choose one of the options, toxicity, fine-tuning with reinforcement learning, or control generation. Okay, so and also I'm thinking to make this project as a group assignment, so you can work as a group of two, or no, if we need more people. So um, I I recommend you to look at these weeks, week 10 for quantization and week 11 for um, RAGs and domain adaptation, and think about which homework you want to transform into project. In this case, you don't need to submit the homework, you will just submit this project. Also, you can use as a project your own ideas, maybe interpretation of transformer layers. For example, you remember we talked about um, the interpretation of some um, hidden embeddings, like embeddings of from, like, let's say 12 transformer layer in large language model. So you can look at the attention mask for that embeddings and map to the dictionary of your uh, large language model to get some ideas about which tokens these embeddings correspond to. So in practice, it's done as follows. You use the linear layer from the last transformer layer, which maps to the size of the dictionary, but apply on the intermediate transformer layer. So this is how they get mappings between these embeddings from intermediate layers to the real words. So, okay, let's now talk about the topic of this week. And this week we will talk about chat models, finally. Because if you started working on homework on GPT model, well, you remember that you can force the standard logic language model to work as a chat model, just to continue the phrase. But it's not how we actually use ChatGPT. We use it as the let's say conversational partner. So like asking questions and getting answers. So we won't, even though this week is called reinforcement learning with human feedback, we won't talk about reinforcement learning today. We will talk about this next week or next day, Wednesday. Today we will talk about more general ideas of chat models. Um, So this is just reminder how large language model works. Based on the input phrase, it predicts next token, and that's why we shift. Oh, by the way, I also changed the code from last class. You remember I used the special index in cross entropy -100, which corresponds to ignore these tokens. So I wrote, actually I wrote this the same day, like so last week, to upload correct code for training. And in correct code, we just shift. If you look at the previous week code for PEFT, so you remember we created the ground truth, and instead of masking, we added index -100, which cross entropy understands as ignore index. Actually, you can use, it's a parameter. You can indicate ignore index equals 2, for example, or 5. By default, it's -100. And then in training, I used the output logits, but shifted by 1, because our language model predicts next token. So from token with index, for example, 5, the output token corresponds to the word with index 6. So that's why we shift the outputs by 1. And labels, true labels, we also start with not with index 0, but with index 1. And yeah, so when you will work on the homework for parameter efficient fine-tuning, just remember that we shift our targets by 1. Okay. So then we talked about other models related to BERT, dBERT or T5, which is encoder decoder model. BERT is just encoder model. And we talked about GPT model. And in GPT model, we talked about few shot learning. So the learning without actual learning, without actual training, updating the weights. So today we will talk about the chat models. So a brief history about chat models. The first conversational system was proposed in 1967, ELIZA, and what it was doing, it just rephrased the input from the user, but rephrased in a question. For example, the user um, could write something and the model asks, is that troubling you? So I just rephrased the input from the user. And it was used, it was supposed to be used as the psychological assistant. But even for this very simple model, uh, there was so-called Eliza effect. So people um, animated this model. So they thought that there is a real person because model kind of understands the user, but it just rephrased his words. But because the model used the same words and was interested in the same ideas, people, um, some people, of course, not all, believe that it's a real um, conscious model. And there was a case when a person who tested this model asked another person to leave them alone with a computer to talk about their problems. So um, then there were other models like Perry for also for uh, schizophrenic dialogue conversation. And then in 2000s and 2010, there was more recent chatbot model, which still exists. But it wasn't a real language model. It just used the search agent and was looking for similar answers from the data set. Um, and um, Yeah, it's just an interesting example. What's 2 plus 4, your age of death. So it could provide some answers from the data sets that they used. Um, and of course, people didn't use these chatbots for asking like medical or psychological questions as they do with ChatGPT. There was another model, Tire, from Microsoft, which was trained on Twitter's, and you can see more toxic answers from Tire. So that's why this project was closed very, very fast. But still, Microsoft has mm, some claims from um, um, about their model, which liked Hitler and did like Jews. Um, but again, it wasn't real chat model. It wasn't real language model. Sorry, it was chat, but not language. So the left example provides the picture of Siri interface where you can actually um, perform the conversation. The next models are from Yandex and another one from one bank, a Russian bank. Um, yeah, remember there was the last model from Russian bank. There was an interesting story. A woman asked a question. I don't have this slide, but it's interesting that I can't find a button on my phone. There was a chatbot that suggested to press some button in their app, and the woman wrote that I can't find the button, and the answer from the model was, it would be better to cut off with your fingers. Well, it was in Russian, it was trained in Russian, the text, but how to make the model to be tolerant and yeah, there was another interesting story when you tried to ask GPT 3.5 model a question, who won the race? The model answered, I can't answer the question because I'm not racist. so, so yeah, but this week we'll talk about how to create the chat bot and to force this chat bot to avoid the answers that all the media like Facebook or Twitter will then blame your company, and maybe you will be fired because of these answers. Mhm. Yeah, so the next step is to create goal-oriented chatbots and also polite chatbots. So let's look at this example. For example, you want to use Alexa and you want to ask about movies that you can, for example, watch this weekend. So how do you think we could implement this dialogue system?
Intent recognition from the speech signal.
Yeah, so first we should use the speech recognition, then to do something with recognized text, and then transform back using speech synthesis. So let's look at this, what Robert mentioned, intent recognition. So the next step is called natural language understanding, or simply NLU. The where we actually want to parse our input. So what do you think? How can we process this phrase? Are there any action movies this weekend? So what do you think? How should we use this information to provide an answer that actually user is expecting to hear? Yes.
You'd probably have to process it to text from their speech, and then
Yeah,
maybe,
actually, yeah, we won't talk about text to speech. Yeah.
maybe use a search engine to so that it can come up with like movies that are out right now.
Yeah, so maybe your system should understand where the user actually is living, which state or which city, what is the date today. So Robert mentioned intent recognition. So first, maybe the model should understand what a user is asking for. Is it just chat? with the model, or its user is interested in music performance, or he is interested in restaurants or in movies. So this is called intent recognition. And this is all the part of natural language understanding. Based on these different intents, you can use different models, different scripts, for example, for search of the information. So let's say a model understands that the question is about movies. What else our model should understand? Well, could you remind me?
Justin,
As Justin said, maybe we should know the geographical position of the user just to provide information about relevant features. Because sometimes I ask something in what's called navigator in Apple Maps, and it plots something in different state, and the drive is 3 hours, something like that. Maybe I don't want to drive 3 hours to a restaurant. So yes, here are some ideas. You remember we talked about named entity recognition. So maybe we want to recognize some what are the names, like if you ask about some places, then it should be a place entity and so on. Intent classification, semantic tagging. Then after this parsing of the request, we will use some scripts provided by managers, depending on intent and information, where we should find this information actually. Or maybe we should add the advertisements for this information and so on. So, and after that, getting the information, the model should generate the answer, which is called NLG, natural language generation. So let's talk about the first part in more details. Named entity recognition. Yes, as I said, maybe you want to understand if this is the name of restaurant or the geographical position or person or date. And you can do this with BERT model, as you remember, and you can use pre-trained model. Semantic parsing is another model. We didn't talk about this, but maybe you want to get some attributes of your entity. For example, action movies. You want to watch movies. Which movies? So the attribute action movies. And how to train this model for semantic parsing. Again, you can use BERT or pre-trained models. It's a little bit less strictly defined problem because it's harder a little bit to train the named entity recognition, but still I will upload a link to when we will talk about RAG, retrieval augmented generation. There's 1 or 2 hours video from LangChain, which is a pipeline which helps to build this chatbots or information retrieval systems. And they actually use the pre-trained semantic parsing models, which will actually read your text and return the JSON file with filled in information for your specific task. The other problem is called anaphora resolution. For example, taxi for that bar, which bar? So your model should go back and look at the history of the conversation, or maybe understand the geographical position to recommend bar. Another problem is called ellipsis resolution. When like in our real life, we don't verbalize all the information. We assume that the other person understands us. In this case, what is that left off? So is it a street? Is it a bar? Or is it a book, and so on? And again, you can use pre-trained models which will look for this ellipse resolution. Then, as I said, the next step is to get the requested information. And it depends on the exact implementation, exact problem, which web page you will use to search for the movies, for example, and so on. Yeah, so for example, you can use gradient boosting, like not there's just standard machine learning approaches, or maybe just regular, not regular expressions, but just if statements. For example, if city is that one, if date is that one, just look at this web page and provide and scrap information about the movies. And in the end, the mode in this part, you will get the JSON file with answers to the request. And then you should return this to the user. And this is the last module, natural language generation. Because you don't want to answer user. If you want to watch a movie, you can go to https:// Maybe we want to provide the answer in normal language, like the name of the movie, the name of the theater, and so on. So again, here you can use any large language models, for example, with prompt. Yeah, and this is natural language generation. Now, let's look at this meme. So, yeah, how much time to develop code with yourself and with language model, and how much time to debug the code with yourself and with language model. I think it's quite true. So the first model that was supposed to perform multiple tasks was T0, As you remember, it was trained on different tasks. So but the real chat models that we're using now, ChatGPT, it was started with so-called instruction following. And you can see the difference between just language model, how we create the data for language model, and how we create the answer for instruction model. So we provide like more details. And this is called instruction tuning. So in 2022, the paper instruction fine-tuning, I believe it's called, no, Instruct GPT, was published. And this is the last the last paper that actually describes the ChatGPT from OpenAI training procedures, because after that they made this private, and it's a little bit hard to teach this course, first of all, because it's very recent models, but secondly, most of information is not public. So we actually don't know what ChatGPT is using really behind, and we will get some insights on Friday when Robert will show some prompts that can force ChatGPT to provide the answers that were used for training. But we can use the models, the open models that try to perform as well as ChatGPT, and that's why we actually can at least understand how it's trained. So to wrap up for today, we'll talk about so this Instruct GPT paper contains three processes to create ChatGPT. First is fine-tuning that we covered last week. When you train your model, fine-tune your model on dialogues, because your model was trained on huge amount of data. It doesn't support the dialogue, but if you fine-tune this model on the specific task on dialogues, then it will be the first approximation to the chat model. The second step that we will talk about and the third next time is to build the reward model that will actually provide the a number, like we will treat this as reward, as like if the generated text from your model was good according to the user or not. And the last step will be to train a reinforcement learning model based on this generative model and reward model. Okay, so I think, yeah, this is time. Let's stop here for today. And yeah, we will talk about this Instruct GPT paper next time.